Hello.
Morning, sir.
Good morning, everyone.
Morning, sir.
వచ్చారు ఇంతేనమ్మా ఇంకా స్ట్రెంత్ వస్తారా? ఇంకా ఎంతసేపు అమ్మా? ప్రిపేర్ అవుతున్నారా? 3-1 3-2. హలో. హలో.
సార్
అవుతున్నారా అండి? 3-1 3-2.
చూసుకుంటా ఉన్నాను సార్. ఇంక ఎగ్జామ్ కన్ఫర్మ్ అవుతుంది.
కన్ఫామ్ అమ్మా రెడ్డి.
అదే సార్.
కొద్దిగా ఆ బుక్లు ఈ బుక్లు పక్కన పెట్టుకోండి.
ఏ ఉక్కు లేదు సార్, మొత్తం కాలేదు.
రేపు ఎగ్జామ్
ఎలా కట్టాలి సార్?
అది మరి రేపు వర్కింగ్ డేస్ ఉన్నాయి కదమ్మా, రేపు ఎగ్జామ్స్ జరిగేటప్పుడు మేబీ అప్పుడు ఏమన్నా పర్మిషన్ ఇస్తారో ఏదో తెలియదు. నేను రేపు 10వ తారీఖు కాలేజీకి వెళ్తాను. ఆ రోజు ఇన్ఫార్మ్ చేస్తా ఎట్లా అనేది. ఓకేనా? ఈ లోపు ఏదైనా హెచ్ఓడి సార్ చెప్తే ఓకే, లేదంటే 10వ తారీఖు నాకు కాల్ చేసి నేను చెప్తాను. ఓకే.
అన్నీ చెప్పాడు, ఇంట్లో ఉన్నాయి. ఏమో మరి చెప్పాడు. ఇప్పుడు ఇంటి కూడా ఉన్నా తీస్తాను.
Okay, good morning to all. So all of you please have your phones in mute. Okay. Today our topic is going to discuss about equalization of load or load equalization. Equalization of load or load equalization. Sam Sundar, please mute your phone. Sam Sundar. Okay. So today our topic is that equalization of load or load equalization. So in this case, at any instant, whatever that loads, either we are using light loads or medium loads or heavy loads, we can adopt any load. The load must be equalization that during this operation. So now here we are going to be equate that load, means we are operating number of plants, not only single plant. If we are operating n number of plants, that all the number of plants of the load should be equal, then the term is called as an load equalization. Suppose you are having only one industry. So industry is a number of devices, or the number of motors, or a number of consumers will be adapted for these industries. During that case, the most of that, some of the units should be having some load, some of the units are having some load, some of the units are having some load. So these every loads should be within this one industry, but that industry we should be to maintain for this and continuously load equalization term. So whenever the industry or the mission should be completely maintain that load equal, then only you can term call as an load equalization. Then see, in industrial drives where the load varies between అక్కడ సైన్ ఇన్ కొట్టానా? అక్కడ కింద ఫేస్బుక్ అవి ఉన్నాయి కదా. నువ్వు ఫస్ట్ దేంతో అటాచ్ అయ్యావో దాంతో అన్న, గూగుల్ ఫేస్బుక్ తో. ఫేస్బుక్ కదా ఇప్పుడు అటాచ్ అయింది. అంటే నీ సింబల్ ఇప్పుడు నీకు ఫేస్బుక్ లో నీ ఫోటో ఏమైనా పెట్టావా లేకపోతే ఒయ్యి అని పడిద్దా? అటైతే ఆ సింబల్ దేంట్లో పెడితే దాంతో అటాచ్ అవ్వను. ఓకే. Now see, sorry, the load varies very wide limits over a short interval of time. Example in rolling mills. Now these rolling mills smoothing of top fluctuation load is called load equalization. Then simple quotation or simple definition, the smoothing out of fluctuation. So without any fluctuation is called load equalization. This can be done by using flywheels. So generally the fluctuations will be getting whenever we are placing the flywheel, it gives a constant output respective of input. Once you are keep as a flywheel, then it will be restrict the fluctuations, then automatically then the restrict of these the flywheels, it will be taken as that the response of an flywheel, there is no problem at all the conditions. Now flywheel it will be takes to restrict all that fluctuations, then we can call as an the equalization of an loads. So while the peak loads it supplies stored energy and charges during offload. Suppose peak load. So the load is categorized in three ways: light loads, medium loads, heavy loads, or peak loads. Once the peak load it supplies to the stored energy and charge during the offloads. Now the load torque required and actual motor torque developed are shown in the chain dotted lines respectively. Then see that picture. The picture will be denotes one axis is x-axis is taken as time and y-axis should be considered as a torque and speed. Now the dotted in upper speed consideration, the dotted lines indicate speed with flywheel and speed without flywheel for dark lines. So without flywheel, then it will be the continuously the dotted lines will be getting during this the torque value, and with flywheel then it will be continuously is taken as that with respect to the time. In a similar way, the torque also should be mentioned for that motor case as well as generator case, whatever that device you have to consider, that all that considerations will be take out from this the area of this and time to and torque. Now see, let coming to for this and the expression of this load equalization, let T1 is equal to load torque when kg meters. So everyone should be indicates in units also. Then T1 is equal to load torque in kg meters and Tm is equal to motor torque developed in kgm. Tf is equal to torque supplied by flywheel in kgs, and T naught is equal to no load torque to overcome friction. J is equal to moment of inertia in kg meter square. T is equal to time in seconds, and omega is equal to speed of the motor at any instant in radians per second. Omega naught is equal to omega is the actual speed and omega naught is equal to not speed of no speed of the no load speed of a motor in radians per second. So where S is equal to slip of a motor from no load to full load. S is the slip of motor from no load to full load. G is equal to gravitational acceleration. So The slip value should be considered as that the no load speed minus speed of a motor at any instant. So simply that will be mathematically expressed as S is equal to omega naught minus omega. Now the load is going to be increased. The value Tm is equal to T1 minus Tf. So when the flywheel decreases, it gives at any some energy E, where that energy expressed as that E is equal to 1 by 2 J by Z omega naught minus omega square. From that expression, E is equal to, we are take out that value J by G, then simply that expression will be turns as omega naught a square minus b square, a square minus b square form you need to apply, that is a minus b into a plus b, then simply can be treated as omega naught minus omega into omega plus omega naught by divided by 2, and therefore E is equal to J by G S omega. Let omega naught minus omega is equal to S. Speed fluctuations with flywheel are not much than the value of the speed is that average speed omega naught plus omega by divided by 2. So power given out by the flywheel, power given by the flywheel dE by dt, that is equal to J by G omega into ds by dt. The torque exerted is equal to power by omega. So already we are mentioned for this and the power formula, that is an J by S omega ds by dt whole divided by omega naught, that is equal to J by G into ds by dt. Therefore Tm is equal to J by G into ds by dt. In case of induction motor, torque exerted by the motor when the gauge and stable position of a speed torque characteristics, whenever it will be in a stable position, at that time the speed torque characteristics is proportional to that is a slip value. Then slip is taken as you can directly to the value S is equal to K Tm, where K for constant, S for slip, and Tm is equal to motor torque. Now again we need to substitute the value Tm is equal to T1 minus J by S into ds by dt. From that equation Tm is equal to T1 minus J by G K into dTm by dt. From that expression we need to modify the value as that equation, it is an jk by g into dtm by dt, that is equal to t1 minus tm. Now integrating on both sides, the limits will be taken as initial position t is equal to 0 and tm is equal to t naught. Now here motor is going to be takes for this initial conditions is directly 0. Once it will be taken as motor reaches to torque the value t naught. Now again we are integrating on both sides. then the result is that minus lag E of T1 minus Tm is equal to G by Jk T plus C. So where C is a constant, so that C value directly you can write it for constant term. C is equal to minus log E of T1 minus T0. Then again we are going to be equate both conditions, the left side and right side. Then simply you can treat it as minus log E T1 minus Tm is equal to G by Jk T minus log E of T1 minus T0. G by Jk T is equal to log E of T1 minus T0 by T1 minus Tm. E power G by Jk T is equal to T1 minus T0 by T1 minus Tm, that is equal to T1 minus Tm, that is equal to T1 minus T0 e power minus Jk T. Tm is equal to T1 minus of again T1 minus T0 of e power minus j g j cap T. Say that equation number 1. That is the totally the consideration derivation about that is the value should be increasing for this and load whenever that the instant case or a rising case or whatever it cases should be considered, the load is going to be an increase. Yes, at that time the motor torque will be developed, that expression the value T1 minus of T1 minus T0 e power minus jg by T. That is the equation number 1. Now it is entirely for this load increasing case. Now next go for load decreasing case. The flywheel speed is slip is going to be, then the slip value later us take as ds by dt is a negative. Now Tm is equal to T0 plus Tf, then Tm is equal to T0 minus j by g ds by dt, then Tm is equal to T0 minus j by g k dtm by dt. J by g k dtm by dt is equal to T0 minus Tm. Then integrating of this j by gk dtm by dt integral of T0 minus Tm. Then finally the parallelly that the equation will get where the result of an Tm is equal to T0 plus Tm dash minus T0 t power minus g by jkt, when Tm minus Tm dash is a torque of a motor at instant is load is removed. Okay, this is the concept of an load equalization. Next we will see that it is entirely the first unit and theory part is over. Now the problems it should be covered in our EM1 EM2. The simple formulas and simple calculation purposes will be available in your first chapter. Okay, now we will see one problem is we will solve, then after we have to solve it. The simple analysis problems, already these problems we are covered in our the previous semesters. Okay, that all the problems should be taken as that the result of an each and everything the problems. Now see is the problem. Now these are all the problems are over in your previous semester. Just I have to show it one simple problem, then after you have to solve it. Okay, then see the first problem. See, a 440 volt shunt motor while running at 1500 rpm takes an armature current of a 30 amps and delivers an output of 50 hp. With the load torque varies the square of a speed, they calculate the value of a resistance to be connected with a series with that armature of an reducing the motor speed up to 1300 rpm. So actually the motor is rotating 1500 rpm, so that will be rotate reduces to 1300 rpm. Then what is that value of an resistance to be connected? Okay, so all the problems will be covered in previous semester. See, then first you have to write that given data, that is for this one given data. A terminal voltage V is equal to 440 volts, speed N is equal to 1500, and similarly speed N2 is equal to 1300 rpm. Armature current IA is equal to 30 amps and motor output 15 HP. We have to find out the value of an external resistance RE. Neglecting the armature resistance, we have back EMF EB equal to 440. So already we know that the relation, the torque to NS speed, both are directly relation. So we are having that data that should be taken as that T2 by T1 is equal to 0.751. Then finally T2 is equal to 0.751 T1. So again we know the relation T is directly proportional to pi into Ia. So pi into Ia is the already we know the value for the current Ia1 and Ia1 value. Just you have to place it, we will get the result of an Ia2, that is 22.53 amps. When external resistance is connected, so at that time the formula back EMF EB equal to V minus Ia2 of Ra plus Re. So from we are having all the data, just it should be the place it for the previous analysis. Now it should be taken as directly we will be getting the result of the previous value. Now here it will be considered as, that is that again we are having that form is that the back EMF to directly relation of this and speed to voltage. Now here E1 by E2 is equal to N1 by N2. So from this analysis we are substituting R value, we will get 2.6 amps of the external resistance value. Okay, this is that our the external the resistance should be taken as that in some case of any value should be calculated. So likewise the all the problems should be initiated for this the case of an this all the values, and it will be taken as that the each and every should problems should be take out, that is then the equalization of motor. So each and everyone should be concerned with that of an the motor as well as that motor output. The motor output is regardless of this input, then directly you can take that output. Okay, this is about our first unit. This first unit entirely the PDF will be sent to in this group, so you have to prepare it. Okay, tomorrow I will start for second unit. The same problems will be have to work out. The same it is also is covered in M1 M2. That problems will be repeated. If you know that formula, then directly you can solve it. So okay, I will send this material to you. So please enter your hall ticket numbers on chat box. Okay, thank you guys.